Okay, so we got the back wheels off, got some new fresh tires on it, some fresh 295s. They're looking good. You can see we ended up having to run just a small wheel spacer to get a little bit of clearance up there. Even this 14-inch wheel program, man, is a big-ass wheel. So big wheel, big tire combo, and these cars, even, they're just not very big if you don't fully back half it. So you can see, like, this thing still has, like, some of the factory sheet metal left in it because I didn't want to be completely cheated up, but after all of said and done, like, I probably would have just gutted the back of this car and left leaf springs on it and been like, whatever. So my leaf spring program worked out. So this is a S10 front section. So it only has a 2.5-inch tab width. The bushing width in the front is 2.5, but the segment was longer. So from the eyelet to the center was longer than the Chevy 2 was. So I used this segment because I just had springs laying around, so that's what I did. But I ended up actually having to add a second spring to this combo because it actually wouldn't hold the car up. It would just flatten the spring out, and what it actually do is like knuckle over, and it would just bend right here, like it had this S shape. You couldn't do anything with it. So we actually ended up making an adjustable middle bracket right there, move the slider forward, trying to take a little bit of the angularity off of it, so giving it a little less, oh my gosh, what we call it, a little less advantage, right? So maybe it bend the spring a little less. That didn't work, so this is when we ended up, so this is now the back segment, believe it or not, of a Silverado spring that we chopped off, and then this is the Chevy 2 spring that we chopped, and then we made this little clevis to clamp it together so the thing didn't fly open. Yeah, so I'm gonna actually, there's a couple of spring manufacturers local. I'm actually gonna talk to them and see maybe there's something to be learned here. Like maybe I could figure out what this actual spring rate is back here. I can match this arc, because as you can see, man, this housing hangs really far out of there. Like it makes a lot of travel. We ended up having to make longer link arms than we thought what we needed, and move the anti-roll bar. We actually had to move the space anti-roll bar up because of the rotation. Like there was a bunch of things that changed in between the first video that we made and this one. So, but it fully, like this is a 9-inch travel. This is a 9-inch travel Viking. You can see that there's still space up there, right? And it's locked. It's actually hanging on the shock. So the suspension will go a little bit further down than it is right this second, but I feel like it already has more than I need. So I'm just gonna leave it the way it is. And so our next limiting factor is really from here to here is 7 inches. So shock has 9, this has 7, so we got a mechanical bump stop, limiting some stuff there. So we were just finishing up putting the shock sensor on right there, and then we have the new traction bar that has a pressure sensor in it. So you can see how much I set this traction bar on the ground, just touched right here, right, and just made it neutral. You can see how much this changes. So this traction bar is long enough to match, obviously, the eye-to-eye, blah, blah, blah. We started off in the very top hole and ended up 2 holes down. But a side effect of this adjustable front box is that these rocker pivots have a lot of clearance when you're driving around. It's actually super satisfied with how much more clearance I have. Obviously, I have a bigger tire than I did on the blue car, but same rocker pivots and the 295 plus this raised up point, it's really nice. Like, because normally these rocker pivots stick way down under the car, and there's actually some good space there. So it pulls into my driveway without actually hitting the ground. So I think that's fantastic. A little hint. So, you could see that the bolt hole is actually covered up. I'll move the camera here. You actually see that you couldn't be able to get that bolt out of there. If you take the whole traction bar off, you can actually rotate it to there, and you can get the bolt out. Now you start going up, and you're gonna start losing clearance. This only works for this hole, and I bet it'll work for this third up hole, but it probably won't work on the top one. So, but I can still make some bar changes right there if I so desired. That moves free and clean. Anybody that has one of my traction bars knows that I make these aluminum spacers that go in there that actually registers and locks and sets that gap. So this thing is rigid from there to there. And now you can see the traction bar. My math on the computer worked out great. And that thing just slides right up in there, looking cool. So Another little thing that I discovered, that much negative pinion angle totally shakes. It's not like violent, but you can just feel it, right? You can feel it in the seat of your pants a little bit. Worse on decel. The reason it's worse on decel is which way is driven, right? So if this is driving, it wants to go up. If this is driving, like the tires are turning it, it wants to go down. So when it wants to go more, when it wants to go down more, it's actually making that angle worse. So I actually have like some pencil drawings that me and my brother did, or some napkin drawings about making an adjustable housing perch that has like kind of a little cool machine setup that's gonna have some variable bolt hole things in it. This thing's probably, because this is like an old housing that I was still using the Rhodes parts. This is an old housing. I want to update this thing to one of my new whiz-bang fancy housings. So this might be the test mule for doing an adjustable perch. So that way, making all these adjustments, we can still make this stuff work. So yeah, you can see only got a little bit of clearance left right there, but this thing actually has a full drive shaft enclosure. So I don't want to be going 170 in this thing and then the drive shaft try to chase me through the car. There's still just, not that much sheet metal in between there. So yeah, so there you go. There's kind of a little update right there. Mike's got this, for all the nice stuff that we make, we can also hand make aluminum brackets to mount shock sensors. So it's great. This thing's got the orange tune up on it because blue is unlucky. So we're doing orange on this car. The orange is an ode to Lance. So yeah, then when we added this extra spring to the bottom, we ended up having to put longer tabs on here. I would love to ditch this weight because this is more heavier, and but we needed it because it would not hold the car up. So this eye to eye is longer. We've shifted this center line here. You can see that this has been shifted here, that's been shifted. So normally this spring sticks out to here. So I have a little bit of research and some stuff that I want to figure out there. I'm kind of interested. Oh, I just thought of something too. A little pro tip. Add yourself some jack pad stuff. So this car, when we moved the stock, like this is where the stock sheet metal stuff is supposed to go, and the stock like spring mount is like in this area right here. So it's normally, you would rack it from here. Well, all that stuff's gone, right? This little flat bracket welds to the floor and it's actually connected to the cage up there. Easy spot to rack it from. And then this forward tube of the chassis, we added one of these too. It's really easy to catch there and put that thing on there. So that's a, while you're doing this stuff, notch you little piece of tube, put a flat washer on the end of it or a cap, and you can weld that on, and it's really easy to rack your car. So yeah, there's a lot of stuff jammed in there. The gear vendor barely fits, all the chassis tubes. But it's pretty good. It's pretty good. Hopefully we can kind of sort of go fast. I really got my eyes on getting a motor for this thing so we can really haul ass. I'd like a nice 427 or something. If anybody's got one and they want to give it to me, then let me know. That'd be great. I'll test it for you, make sure it's good. All right, so we added a pressure sensor to one of the traction bars. I'm probably gonna add both just because why not? Because it's more data is more data, I guess. I don't know if that's better data, whatever. So anyway, I got this cool little, I always wanted one of these things, and so we got one like 2 years ago when we got the belt sander. Got one of these welding positioners. So I got this thing set up, the old 351, but yeah, so we had to shorten the traction bar link in order to put the load cell in it. So I'm gonna just go ahead and get this thing welded in, and then not as good as some of the guys out there, but it's consistent and it's definitely welded. And I don't know if you caught on the time, but that's pretty quick. See it coming back around. So it's a little bit slower than I can go, which this little control has whatever that setting means. I'm not really sure, but it's like 15 on this little scale, and that seems to be pretty much the happy spot. So it's slower than I could weld, but it gives me time to adjust. So yeah, so that's welded up. Let that cool down a little bit, and then we'll start putting more parts on it. All right, so here's kind of another piece to the puzzle of converting this thing over. I wanted to put this pressure sensor in the traction bar, and so got the traction bar shortened up. Right, it used to be that much longer right there. And now this thing is going to go in its place. It's kind of a cool piece. It's really just like a hydraulic piston. I feel like I can actually just make it. You know, maybe I will next time. I don't know, whatever. Any rate, so you thread your sensor in right there. You're supposed to use anything but brake fluid according to the instructions. So you put some material in there. Or sorry, you're going to thread the sensor in there. The bleed hole right there. Fill it full of some sort of liquid, non-compressible liquid, and then yeah, so basically it's just got a plunger or a piston in there, squeezes on it, makes pressure inside of it. So I'm really actually super interested to put this on there and then like crank some preload into it. Like, what does a turn, 2 turns of preload actually look like on that bar? Like, how much pressure is that making? And then it'll be extremely interesting to kind of look at what that data looks like going down track. So yeah, I'm excited for just learning some new type of stuff. So anyway, so we shortened this guy up, and so please disregard the black paint on my brand new rod end. The painting guy down the way got a little overzealous when he was painting the inside of the car, and not all the holes were patched, so yeah, so we got some paint on the rod end. So all these systems that I have like this use this reducer bushing that goes in there and makes that thing 1/2 inch, so you can get more holes and it's way easier. And then also that bushing goes in there, and so when you go to slide this in, it's retained, right? So it's really easy to slide this up in there. So the problem is that's 3/4, this is 5/8. So I was just gonna do a 30-second tutorial on my laptop right here on how to make this little bushing. So yeah, I'm gonna add this into the video. I think it's cool. All right, something else to take note of is when you're doing some swaps like this is a 3/4 rod end, and the head width on this guy, or the ball width, let's see if we can make it so you can actually see it, is 0.875. So this is 7/8 wide right there, whereas my new 5/8 rod end, the head width is only 3/4. So I'm actually going to have to make this step in this bushing, this width right here is going to have to be bigger too. Smaller OD here, bigger step bore right there, or step width, I should say. All right, so I feel like I do probably way too much of this videoing my computer screen thing, but whatever, it works. Okay, so there's what my reducer is going to look like, 5/8 right here. And then I've got the width established, so here is the sketch. So when you come in, you draw, let's see if I can get zoomed in right here. So this is the rod end ball width. Here's the center line. I've got 50 thousandths gap in between it to make sure that they don't actually touch, otherwise it'll hold this off the edge. You can see it's got little pin C action. Actually got some goofy looking line going on right there. I need to delete that line. But you can see the shaded area is actually what's gonna make. 150 thousandths right there. Got a little radius, and so then I ended up having to reset the actual spacing right there to 7/16 in order to get that. And then there's your 3/4 inch. Come on, readjust here. So then here's your 3/4 inch right there. That's that rod end ball width. So you can see the geometry to drive this is actually really simple. Hit finish sketch, right? And then you're just gonna do a revolve extrude right there. Makes your round part. Throw a couple fillets at it just to clean it up, and then come into your manufacturer. right? And this shows you kind of like what the lathe is going to do. So go at setup and hit simulate. So here we go. It's going to go a little bit fast. Knocking the material down. Finish. Drill. Part off. Boom. Done. So there you go. So I actually already made this thing. And so what I'll do is cut most of the part. And then I've got my rod end right here. I've stopped it before it parted it off so I don't end up with a bunch of bad ones. And then I'll just verify my fitment. That's really, really nice. So excuse the ridiculous amount of material sticking out of there and making those the traction bar pins right now. So, but I had to jump over and make these real quick. So yeah, there you go. There's that 5/8 rod end. And you can see that it's just really, really nice. So CNC lathe parts are awesome. So there we go. Next up, put this bar on. All right, there we go. Ready for install. Got the pressure sensor in there. Got a 1500, so I think that's gonna be more than adequate. Got my reducers. This thing is ready to go. So let's go put it on the car. All right, so Mike just got this bolted on. We're gonna lower it down and fix our window net because I can't order things properly. So we had to order a generic window net and make some ghetto tabs, but whatever. Lance doesn't think we're gonna make it till LS Fest, but we're probably gonna make it. We're mostly gonna make it. We'll see what happens. There, so there you go. So got the load cell bled. It's kind of interesting to bleed because it doesn't hold very much fluid and it doesn't have very much travel, but it's in there, so it's cool. The rod ends fit. Got the wire harness. Mike's gonna tie that stuff up. It's gonna do one of these numbers. We're ready to rock and roll. So yeah, we're gonna lower this thing down. Matt's gonna finish the window net. And I think we have a couple other things on the list, but I think we're almost I think it's almost ready, which is crazy. It's a week before we're supposed to leave. So something bad's definitely gonna happen.
Yep.
There's just no way.
Where's the meteor?
Where's the meteor, right? Yeah. Yeah, so.
We already had the earthquake.
Yeah, we already had a giant earthquake, so yeah, we got that out of the way. So, okay, well, let's see what happens. All right, so I started that video a couple of days ago. In fact, it was overcast, and now it's sunny. Saturday, trying to get ready to make this LS Fest deal. So this car definitely looks good with the 295s. I can't lie, I'm digging it. And those springs that I cut in half and did all this debauchery to, I wanted to show you kind of, I got the sensor, the shock sensor hooked up and all that stuff. And so I'm getting ready to rack this thing. I've got a couple little pieces that I need to deal with to get this thing in the trailer today, so I don't have to deal with it next week. This was playing. I got the bump box. We got the bump feature to work through the Holley last night, which is cool. The data's clean. You can see this is the front shock, you know, blah, blah, blah. It's working out good. So what I wanted to do is bring the live data up and actually pick the car up in the air and then kind of show you how much travel that spring actually makes from ride height to extension. So you can see the ride height there in the beginning of the video. I'm gonna get this thing, get this data pulled up so you can see it. Okay, so you can see from here the rear shock sensor sitting. This is at ride height. This is has 3.7 inches of travel remaining, so that's where it'll bottom out. It actually won't achieve that because I only have about 2.5 inches of travel to the where the pumpkin hits the sheet metal. This is the reality of leaving stock sheet metal in your Chevy too, is that they appear low, but they're not that low. There's nothing you can do about it. So you can also see right here, passenger bar pressure sensor. So I did that earlier in the video. I showed you adapting over that passenger side bar to have that pressure sensor. I set this neutral yesterday where it had nothing, and then this is just like the deviation of the tire pressure, making it so the ride height is slightly different, and there's making that much pressure inside of the bar already. You can crank. We cranked one turn of preload into it and it made 700 PSI. So one turn of preload evidently is quite a bit. It also raised the shock height by a tenth or 2/10 of an inch. I don't remember what it was. So I could do a little more digging and show you that later. But yeah, so putting that preload in most certainly adds weight to that tire. So I'm just gonna go ahead. I played with this last night and was bumping in just making sure that this thing would actually bump properly and see how far it would bump. I found that holding about 200 PSI on the brake definitely made better as far as smoothing the bump out. And then I saw it pegs the 1500 PSI sensor. Every time you bump in, bink, 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 right? It pegs the bar sensor. So I'm not really sure that 1500 PSI is anywhere close to enough. So I'm gonna go ahead and order a 5000 and slap a 5000 in there, and then order the parts to put the driver's side one in as well, because why the hell not? So yeah, I'm going to get this thing so I can aim the video at it and then pick it up on the rack, so. All right, well, I don't know how good this video is gonna turn out, but got the camera aimed at the data right there. And you can just watch that shock travel sensor extend. It's pretty cool. Okay, off the ground, shake test. Okay, what do we get to? 9.5. So 6 and 6.8 inches of travel. So 6.8 inches of extension travel. That's pretty impressive. So that's a little other little side note on this. I'm going to open up this for anybody that wants to know how I set up the bump box and the Holley. I figured I could show you real quick. Because why not? I'm sure there's all kinds of videos out there already that probably show all that good stuff, but I have this Mike's transmission, 210, 140 gear set, reed case. It's a super nice piece, but it has the big bulky external trans brake solenoid, clank, 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 right? It doesn't have like an internal brake. And I used some settings from Kevin with his Corvette, and his settings won't release at all. It won't bump zero, like it won't move. So I found that maybe that's the difference between like an internal brake, how much faster or how much different the circuitry is versus this big old clunky thing. So yeah, let's flip this thing around and just do a quick little explanation. Okay, so you got your trans brake relay. So this has just got one of those solid state relays that is pinned into the ECU, pulse width modulated ground. And then on our input end, we have our bump button, 0 to 20 volt. Make sure that it's 0 to 20 volt, or 20 volt setup. Let's see, can you see that? Yep, 20 volt setup. In our turbo menu, input, output, we've got trans brake launch right there, configured as 12 volt. And then got the scramble on too, but I didn't define it yet. Not that I even think I'm gonna use that, but whatever. I was going to reuse the bump button because I'll explain to you how you could do that. So I was going to make the bump button as a scramble, so I didn't have to have multiple buttons on the steering wheel. So when you go to your output, your input-output deal, go back to our output, go to configure. So this is a pulse width modulated ground. I've just got power hooked to that solid state relay. Then the ground goes into the ECU. Go to configure. So this input will activate when trans brake launch is enabled, right? So set the trans brake button. And then also you need drive shaft speed to be below 25 miles per hour. So as soon as you have some drive shaft speed, you can't reset the trans brake button, right? And then you're gonna go over here to your PWM setup. I've got it set at fixed, frequency at 60. 60 is an arbitrary number. You could put all kinds of numbers in there. I chose 60 because our power is on 60 hertz, and I don't know, it sounds good. I left it on TPS for the x-axis right here. It's kind of irrelevant. You can obviously change all these numbers based on what you're trying to do. You could put RPM down here, so you could have a different amount of bump based on the amount of RPM that you had. Or you could put temperature, like transmission temperature. So say the temperature of the transmission fluid was hotter and it bumps further, so you want to reduce the off time. If that makes sense. So then I've got my bump button right here, 0 to 20 volts. I arbitrarily split it at 8.5 or 9 right there. So anytime the trans brake button is on, but the bump button is not on, you have 100%. So the trans brake's just on. As soon as it sees the bump button on, which it's gonna jump between 12 and 16, say 15 volts, depending on where the alternator's at, right? Or if it's the battery's down a little bit, then it's going to jump up to 50%. I started off at 90% duty cycle, and it wouldn't do anything. 75% wouldn't do anything. 60% wouldn't do anything. It wasn't until I got to 50% that I could actually get the car to release. So if you hold the button down, the car just drives away. If you just bump it, it lurches forward somewhat aggressively. And so I have brake pressure sensors in this car front and back, and so I just make sure I have 200 PSI on the rear brake, right? Because the bump is coming from the rear brake, so 200 PSI, and or maybe it was 150 PSI. So it was like 350 in the front, 150 in the back, something like that. I could go back and check, but a little bit of brake pressure on there, and I was drastically able to reduce the jerky sensation of the bump. So it actually bumps in relatively smooth and easy, no drama, and it works really well. So yeah, I think well, as you can see, it's almost dark outside. Mike's bringing the forklift in, but this thing is ready to go in the trailer. We did not get it in the trailer today like we'd hoped, but that's okay. It's okay. Boost controller works. I got it configured to where the bump button also doubles as a parachute release, and so I just have all the criteria set up in the Holley to make it so that's the case. Bump button works. The parachute release is arms, has air to it. We got our little air compressor in there. That's dialed in. The first time I drove it, so we were trying to trying to make this thing like drag and drive, so we put like regular LS coils on it. Well, went out there on the road and made a little pass on it, and it was just popping and banging. So I'm like, you know what? Let's just put the smart coils back on it. So that's what we did. So we put the smart coils back on it. All the boost control stuff works. I know I've said that like 9 times now. So smart coils are on. Ordered some more spark plugs. That's all set up. Got the alignment dialed in one more time. It was good, but made a little adjustment and got that a little happier. The shifter shifts, so that's cool. And yeah, dude, the car is ready to go. We're gonna do our Easter thing tomorrow morning, and then breakfast and all that stuff, and then we're gonna load the golf cart, load the trailer, come back over here, stuff this thing in there, and then yeah, make excuses as to why we didn't go later on. So no, we're going. I'm just kidding, but it is funny. So okay, signing off. Until next time, YouTube.